Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's Scribblecast of Organic Chemistry lectures and solutions to homework problems. In this Scribblecast lecture, we are looking at the solutions to the fourth problem set on nomenclature found at the end of the nomenclature section of the handout notes. In this section, we were asked to write an IUPAC name for a series of molecules. The first molecule that we were asked to write an IUPAC name for had a chlorine attached to a CH2, which I believe was attached to a double bond, which is attached to a carbon with a hydrogen that had this NO2 group attached to a CH2 with an OH. Now, when providing an IUPAC name for such a molecule, you must find the longest carbon chain with the highest priority group. We have a chlorine, a nitro, and an OH. What is the highest priority group? Well, it is the OH group, or the alcohol. The longest carbon chain is 1, 2, 3, 4, 5. An alcohol on a 5-carbon chain is called a pentanol. The E is dropped and OL is added. Except in this case, we have at carbon 3, we have an ene. So this becomes a pent-3-ene. Because the alcohol can come at any place along the chain, you have to indicate that it's at carbon 1 all. Pent-3-ene 1-all. We then have a nitro group of carbon 2 and a chloro group of carbon 5. The C of the chloro comes first alphabetically, so there's a 2-nitro in front of the pent, and then the 5-chloro. All one word. 5-chloro, 2-nitro, pent-3-ene 1-all. Question 2. We have 3 chlorines bound to a carbon, which is attached to a CH2, who's attached to a C double bond O, which has an OH off of it. While the longest carbon chain is 3 carbons, that's a propane, the highest priority group is the C double bond O with the OH, or carboxylic acid. In order to name the carboxylic acid, we have to drop the E of propane and add oic acid. So this is a propan 1-oic. But the interesting things about carboxylic acids is they always come at the end of chains. Hence, it has to be 1. So the 1 can be dropped, and you can just say propanoic acid if you want. And the propanoic acid is 2 words. Propanoic acid is 2 words. Now we got the 3 chlorines. If we number, they're at carbon 3, so it looks like we have 3, 3, 3. Trimethyl. Propanoic acid, and that's all one word. All of this is one word, no spaces. Okay, so acid's a separate word, but 3,3,3 trimethyl propanoic acid is one word. Question 3, a bit tricky. We have an aromatic ring with the CH2 and an NH2. Now, I recognize that the NH2 is placed on the CH2 in place of a hydrogen. If there was a CH3 and no NH2, this would be toluene. When you pull off a hydrogen of a toluene, you get a benzo group, and this looks like benzylamine. Now, if you put benzylamine down as your answer, you must remember the question asked for the IUPAC name, and you were instructed that benzylamine is a common name. And for this course, we'll treat it as a common name. Now, IUPAC does sometimes accept common names, but for this course, I want you to use the alkylamine methodology for common names. So this would be a common name. And I wanted you to keep with the IUPAC method of naming amines. And what's that? Well, that's to find the longest carbon chain with the amine, drop the E and add amine. So you'd have an alkanamine. Well, what is the longest carbon chain with the highest priority group? In this case, highest priority group, NH2, 1 carbon, 6 carbons are an alkyl substituent. It looks like we have a methanamine. Yes, you could say methan-1-amine, but with methane you only have 1 carbon. So it has to be 1. So saying methanamine is fine. Off of the methane we have a substituent benzene. And benzene acting as a substituent is a phenyl group. And so we could say 1-phenyl. But again, since there's only 1 carbon, the phenyl need not then have the number. So phenylmethanamine is the proper IUPAC name, whereas benzoamine we're using as the common name for this course. Alright, so you're going to learn both methodologies. When asked for an IUPAC, give the IUPAC. If you asked for the common name, you would have given benzylamine. Let's go to question 4. Just racing through these questions. Question 4, we have 2 CH3s attached to a carbon. Which is attached to an oxygen. The oxygen's attached to C double bond O. And then we have a CH2 and a CH3. Now you were asked to find the longest carbon chain with the highest priority group. And whenever you see this type of functional group, you have a special act you must carry out when attempting to derive the name. The functional group here is an ester. When you have to name an ester, you were instructed that you must find the carboxylic acid group from which the ester is derived. Right here is the carboxylic acid. You were told, take the alkyl off the oxygen and scrap it and rewrite the carboxylic acid. So just replace that alkyl group with an H. And you get this carboxylic acid. You were instructed to name the carboxylic acid. Well, it's a 3-carbon chain. That's a propane. So drop the E ending and add oic acid. This would become a propanoic acid. Now you were told that in order to name an ester, you must drop the ic acid ending of the acid and add ATE. So this molecule becomes a propanoate. Propanoate. Now you can name this alkyl group that's off of the oxygen. And that alkyl group is an isopropyl. An isopropyl. And so the name of the molecule is isopropyl propanoate. In question 5, you have another ester. It has this strange thing off of the oxygen. C double bond O and a CH3. Again, you should generate the carboxylic acid. On scrap paper, you'd write this. You'd figure out the IUPAC name of the carboxylic acid. 2 carbons would be an ethanoic acid. So ethanoic acid, 2 words, drop the ic acid because you have an ester, add 8, and you would get ethanoate. Ethanoate. Now, what is this group off of the oxygen? A 3-membered ring. A 3-carbon ring is a cyclopropane. But when you pull an H off and you make it a side chain, as a substituent, it becomes cyclopropyl. And so this is a separate word, cyclopropyl. Okay, I'm going to have to write out the ethanoate again. Cyclopropyl, 2 words, ethanoate. 2 separate words. All right. What if in this case you were asked for the common name? Well, to get at the common name, you must look at the carboxylic acid. You were told the common name for this molecule. The common name for that carboxylic acid was acetic acid, and in fact you were asked to learn this common name. Now, if you do the same function for esters, that is, drop the ic acid and add 8, instead of ethanoate, you'd get acetate. With the cyclopropyl in front, you end up with cyclopropyl acetate. However, that is the common name. You were not asked for that in this question, so you did not have to give it. So read the question carefully. If the question says IUPAC name, give cyclopropyl ethanoate. If it asks for common name, give cyclopropyl acetate. If it says give an acceptable name, you can give either the common or the IUPAC name. But as stated, in this question, we had to give the IUPAC. Question 6. Roman numeral 6. We have in this case an H attached to a C double bond O to a carbon that has an H and a chlorine off of it. This is attached to a carbon who has an H and an NO2 off of it, which is attached to a carbon which has an H and 2 methyls off of it. So, again, how do we proceed? Well, we find the longest carbon chain with the highest priority group on it. In this case, we have a chlorine, an NO2, and methyls. The highest priority group is the C double bond O with an H. An H attached to a carbonyl is an aldehyde. Aldehydes are named by taking the alkane and dropping E and adding Al. We have 1, 2, 3, 4, 5. A 5 carbon chain is a pentane. This becomes a pentanal. Now pentan 1-al should be written, but since aldehydes come at the end of the chain like carboxylic acids, if they're the highest priority, they have to be 1. They can't come anywhere else. So it's perfectly fine to say pentan. You can write the 1-al. You certainly can do that. You can write that. Or you can equally just say pentanal. It's perfectly fine. Okay. Now we have this methyl as a substituent, a nitro, an NO2, and a chloro. Well, the C is certainly alphabetically first. M is next for methyl, and nitro will be last. We can number 1, 2, 3, 4, 5. We have a 3 nitro, 3 nitro, a 4 methyl, and then we have a 2 chloro. So 2 chloro, 4 methyl, 3 nitro, pentanal, or pentan 1-al. Excellent. Question 7. Question 7, we have a CH3, CH2 attached to a C double bond O. The C double bond O is attached to a carbon that has an H and a CH3, and it is attached to a CH that has 2 CH3s off of it. Okay. Again, we must find the longest carbon chain with the highest priority group. When you have only carbons attached to carbonyls, you have the functional group ketone. In this molecule, the ketone is the highest priority group. Longest carbon chain in this case is 1, 2, 3, 4, 5, 6. Numbering from this way, 1, 2, 3, 4, 5, 6. And numbering alternatively, we would get 1, 2, 3, 4, 5, 6. We give the lowest possible number to the highest priority group. The blue gives us a 3 for the ketone, whereas the red gives us a 4. 3 is better, so I will remove the red numbering system. Okay, now when naming ketones, a 6-carbon alkane is a hexane. We drop the alkane E and add -one. So this is a hexanone. In this case, you have to place the number for the position, hexane, 3-one in the root. The reason is that carbonyl for the ketone could come at different carbons. We could have had a 2-one. We could have had a 5-one. So we have to be careful when we're working with hexane ones to insert the number or locant for the functional group. And then we see we have a methyl group at 4 and a methyl group at 5, so we're going to have a 4, 5 dimethyl. 4,5 dimethyl hexane 3-one. Excellent. Question 8. Roman numeral 8. Here we go. We have a rather large structure to draw. We have a CH3, followed by 2 CH2s. Then there are 2 CHs. Followed by 3 more CH2s. And a CH3. Off of the first CH, I have a CH with a methyl and an ethyl off of it. Off of the other CH, I have a CH2, a CH, and then 2 methyls off of that CH. Okay. Since this is just an alkane, there is no priority group, and so we look for the longest carbon chain. And so we start counting on our alkane to find the longest carbon chain. And if we start counting, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbons. Let's count here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 9 looks like it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we have 2 9-carbon chains. We have the chain that goes straight across. And then we have the chain that goes from the right to the furthest CH and curves down and continues on. Right? So that's this chain. Which 9-carbon chain is chosen as the root? Well, when there's a tie, IUPAC rules state you pick the chain with the most substituents. If I go straight across, I only have 2 substituents, one there and one here. So I get 2 substituents when going straight across. If I follow the curve down, I get the methyl as a substituent here. I get this group, and I get this group. The little bend gives me 3 substituents, and 3 substituents is better than 2, so I follow the bend. Now I can number this way, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I can number 1, 2, 3, 4, 5, 6, 7, 8, 9. If I compare both numbering schemes, the first point of difference, first substituent on the blue is a 3-methyl. The first substituent in the red is a 5-something. And that 5-something, 5 is higher than 3, so again, red is not used. We go for the lower numbering on the first substituent that we hit. So, we now have our numbering scheme, we have a longest carbon chain, we're ready to name this. No problem. This is a nonane. A nonane. And at carbon 3 we have a methyl. Okay, so I have a 3-methyl. At carbon 4 I have a 3-carbon propyl, so I have a 4-propyl. And at carbon 5, what is my substituent? Do you recognize it? If you look carefully, you will know, if you've studied, this is an isobutyl. So we have the I of isobutyl, the P, and the M. So I will come first, then the M, then the P. So we have a 4-propyl. 4-propyl nonane. In front of that we have the 3-methyl. And in front of that we have the 5-isobutyl. So 5-isobutyl, 3-methyl, 4-propyl nonane. Well, there you have it. The solutions to the 4th problem set at the end of the nomenclature section. Thank you very much.